I'm gonna show you how I made this unique automatic plant watering device. Let's get started. Hello there, I'm the creator of Build Anything, and in this video I'll be continuing the remote plant watering project. The thing that makes this version unique is that most use Wi-Fi or just make it automatic, while my version uses SMS messages to give you full control anywhere on the world. So keep watching until the end to see it in action. Also, comment if you think this video is better than my other ones. I've put a lot of work into the voiceover and thumbnail, so I'd love to hear your opinion. First of all, this is part 3. If you didn't watch part 2 or 1, there will be a link in the description, or you can just click on the card right here to go to that video. The first thing you're gonna need is some kind of water container. Once you found one, drill a hole in the top so air can enter. Then drill another hole at the bottom and connect the hose. Make sure it's waterproof, because water and electronics don't really mix. One quick tip, just buy epoxy. Hot glue or maybe even tape is okay when you're making a normal project, but when it needs to be waterproof, you can save yourself a whole lot of trouble by just buying epoxy. It's a little more pricey, but believe me, it's worth it. Now that you've attached the hose to the container, you can once again use some epoxy to attach it to a 12-volt water pump. Right now the other side of the hose is leading back into the container, but that's just to test out if the pump works. Normally this side would go to the plant. Now if I just use a 12-volt adapter and connect it to a pump, you'll see that the water starts flowing rapidly, and that's just what we want. You can pause the video right here to see how I connected the pump to the Arduino. I advise you to make a quick Arduino sketch like this one. Then connect the Arduino with the pump to your PC and put the hose in a measuring cup. That way you can change the timings and note the exact time needed to pump a certain amount of water. I noted all the timings one by one and ended up with this. Now I can use all of these timings in the final sketch. Well, not entirely final. I'm still going to make a few changes in the next video to kind of clean it up and make it more efficient. Now let's go over the sketch I made for this project. I'll only be explaining the changes I made, because otherwise this video would be way too long. If you want to know how I made the rest of this sketch, you can go watch part 1 and 2 after this video. Link to both will be in the description. So, the first thing we do is we make a new constant variable. That means this variable isn't actually a variable because it never changes. The only reason we do this is so each time we refer to pin 12, we can just call it pump, because as you might have seen in the circuit image, pin 12 is a pin with which we turn the pump on or off. The next thing we do is we tell the Arduino that pin 12, or as we named it, pump, is an output. Then we scroll down to the part where the Arduino has detected a valid response. Now we can use the timings we noted previously. So water 0 doesn't turn the pump on at all, water 1 turns the pump on for the amount of time that's needed to pump 50 milliliters, water 2 pumps 100 milliliters, etc. One other thing I changed is that when you respond with an invalid message, it not only tells you it's not valid, but also sends you some examples of responses that are valid. You'll see that working in just a second as we test it out. To be sure the Arduino and module communicate properly, make sure the module is off by checking if there's only one red light on. If more than one light is on, hold the button on the side to turn it off. Then press the reset button on the Arduino and immediately after turn on the module. 2 lights on the module should stay on and 1 will be blinking. Now wait about 30 seconds for it to connect to the network. As you can see, I got a message from the Arduino with some data and the possibility to wire it remotely. First, let's test what happens when we reply with anything incorrect. We get a message that the response was invalid, some examples of valid responses, and the possibility to try again. Now let's enter a valid response like water 4, which means 200 milliliters. The Arduino responds with a message saying our response was valid and it will water the plant 200 milliliters. Then the pump turns on and it waters the plant exactly 200 milliliters. Again, I could be almost anywhere. As long as it has power and water, this will always work. Thank you very much for watching. I hope you liked the video, and if you did, please leave a like and consider subscribing. I'd appreciate it.